So, I send a rhyme excelling in sacred truth and rigid spelling, numerical sprite elucidate for me the lexicon's full weight. None the wiser? Let me put it another way. How I wish I could recollect of circle round the exact relation Archimede unwound. Let me put it another way. Let me take a coin, wrap a piece of cotton around it so it overlaps, with a pen, mark the overlap, like that, and then unwind it and put the piece of cotton on a piece of paper. There we are. Now those two marks, if I stretch the cotton out, are just there and there. And if I measure the distance in terms of the widths of coin, it goes 1, 2, 3, and a bit. In fact, it's about 3.2, or this number, 3.1, etc., 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 etc. A very odd number, an important number, a real number, but not a number we can express properly with the numbers we use every day. It's less cumbersome to call it 3 1/7 or 22/7, but even that is only an approximation. And because it's an approximation, we refer to the real number as pi. It's a Greek letter, sounds like something you eat, looks like the letter R, but really is P-I, pi. And it's a very peculiar number because it's a most important one defining the relationships of circles to things. We use it for measuring the area of circles or the volume of a sphere or anything round. And that's where the poems come in, because hundreds of years ago, people used to try and remember that great sequence of numbers that is found in pi. Here it is again. If you look at the poems and count the number of letters in the words, you get pi. 3.1, 4 letters, 1 letter, 5 letters, 9 letters, etc. And people used to write these great long poems and make sure that it followed, in the number of letters per word, the sequence of numbers in pi. This one takes it to 30 decimal places. This one, the second poem I read, takes it to about 13. Well, pi is a peculiar thing. It crops up in many places, not the least of which is when you start dropping your toothpicks on the floor. An odd habit, but hundreds of years ago, somebody did it for hours on end. He got a floor which had planks like this, and the planks were all the same width, and he got a stick which was the same length as the planks were wide. And he dropped, and he dropped, and he dropped. And sometimes the toothpick would land on a crack like that. Sometimes it wouldn't. It would land on a board and didn't cross a crack. And he kept count of two things. One was the number of times he dropped it, and two, the number of times it landed on a crack. And if you do that, and you mark them down on a table, you get some interesting results. I've done 99 here. I'll drop it a last time. It's one more drop, 100, and it landed on a crack. So out of 100 drops, I got 63 on a crack. And this is what you do. You take the number of times you drop, that's 100, times 2 equals 200, and divide it by the number of times it landed on a crack, 63. That, believe it or not, is 3.2 or so, close to pi. Not quite pi, and in fact, you can't ever get to pi, but the more times you drop it, the closer you get. And I suppose you get pretty close if you kept going for, I don't know, 25 years or so.